Hello again. We were discussing the concept of Fermi Golden Rule because we are interested to determine the transition rate of the beta decay that is given by the following formula, which here we have one matrix element, here we have one constant, and the third term is a density of the final state. So let's write this again. So the Fermi golden rule could be represented like we saw before, that is 2p over h bar, which multiplies a matrix element multiplied by the density of final state. Usually we can represent the matrix element like this, where we have an initial final state, and in the middle we have the potential or the interaction, and here the initial state, the potential, and or the interaction and final state. The density of the states factor determines the shape of the beta energy spectrum. So, in other words, we can rewrite for the beta decay this this interaction like this, like 1g, which multiply by one constant, that is the strength of interaction, which multiplies this integral that consists of one final state and one another and two more wave functions, one of the electron, another of the neutrino, and these multiply here by another operator, and here another one, initial state. The constant g is the strength of the interaction. Usually the wave function of the electron and the neutrino are could be could be a wave which has this structure that is an exponential spherical wave, and also for the for the neutrino over the volume in Q R over H. So if we expand those exponential, we can evaluate this integral. and we can obtain something like this. Okay, this is barely the expression, okay, that is proportional to 2p. Okay, let me put this another way. Is proportional. I will omit the constants, just I will put the essential constant, that here we have mf I on something that is proportional to pq square, okay, p square q square dq dp dq de. Okay, this is dp dq over te. Okay, so the transition of the beta decay is similar like this. I won't enter in detail, just I wanted to mention the transition probability of the beta decay. That's all.